Hi, 8th grade. Welcome to lesson 3.5, intervals of increase and decrease. By the end of the lesson, I want you to be able to say, I can. Describe the behavior of a function and write a description to go with its graph. Solve and discuss it. Martin will ride his bike from his house to his aunt's house. He has two different routes he can take. One route goes up and down a hill. The other route avoids the hill by going around the edge of the hill. How do you think the routes will differ? What do you think about the relationship of speed and time? Okay, so let's write characteristics of what we think is going to happen on the hill and what happens if we go around. We'll look for participation and press play when you're ready. Okay, so the hill is less distance because you're going straight across, but his speed will decrease when he's going up the hill and increase when he's going down the hill. If he goes around, it's going to be more distance, but his speed is going to stay the same because he doesn't have to work hard to pump up the hill or coast down it. How do characteristics of each route affect Martin's travel time and speed? Well, if he is going more distance, so going around, it's going to take longer. But if he goes over the hill, his speed is going to increase, or speed is going to decrease, which will also take longer. Depends on how good of a biker he is. Turn the page, example 1. An express train reaches its travel speed of 150 miles per hour a short time after leaving the station and travels at this speed for an extended period of time. What does a qualitative graph of the distance the train travels over time look like once it reaches its travel speed? Step 1. Draw a qualitative graph. Qualitative graph represents the relationship between quantities without numbers. Identify the input variable and the output variable in the intervals. So input is time, so how much time the train has been traveling, and the output is distance, how far it has gotten. You can see, an interval is a period of time between two events or points in time. The second interval starts when the train reaches its travel speed. So you can see there's two different slopes here. There's this one, and then this one's a bit steeper, because the first interval is when the train is speeding up. Then the second interval is when the train is at its constant speed, that constant rate of change. So determine the relationship between two variables during the second interval. As time increases, the distance the train has traveled increases. It's a positive graph. This is called an increasing interval because it's going up. Try it. The graph at the right shows another interval in the train's travel, which best describes the behavior of the train and the interval shown. So as time increases, the speed of the train does what? Because we're going down. The speed of the train decreases. So the function is decreasing. If there's a negative slope, it is a decreasing function. How would the graph of the function change if the speed of the train was increasing? If the speed of the train was increasing, it would be steeper because it was going faster. Oh no, that's wrong. Silly Miss Justin, look. We're talking about time and speed. If the train of the speed was increasing, it would be a positive slope, which would be an increasing function, like we saw in the example. All right, example number 2. Interpret the graph of a nonlinear function. Remember, nonlinear, no line. The graph shows the behavior of a ball that a soccer player kicks to a teammate. Describe how the height of the ball and time are related in each interval. So intervals are like where it's broken up, where it's doing something different. When the first guy kicks it, it's going up. Then it hits the middle and it starts to go down so that it could reach the second guy. So you determine whether the function is increasing, decreasing, or constant. So from when he kicks it to when it gets to the middle, interval 1, it's increasing. Then from the middle to where the second guy gets it, it's decreasing. Because as time increases, the height either increases or decreases. So the graph shows the behavior of skyless skateboarding at a skateboard park. In which intervals is the function increasing, decreasing, and constant? So they labeled the intervals for us, but I'm going to break them up for us as well. So here, here, here. Okay, so interval 1, as time increases, the line goes down, so it is decreasing. Interval 2, the line as time increases, the line is not moving up or down, so it is constant. It is staying the same. 3, as time increases, the graph is increasing, the distance is increasing. And 4, as time increases, the distance is decreasing. So you're just looking to interpret the graph. Remember, we read them left to right. In which of the intervals is the function increasing, decreasing, or constant? Again, they labeled the intervals for us. So the first one, it's going up, so that's increasing. Second one, it's staying flat, so that's constant. Third, it's going up again. 4, it's flat again, so that's constant. And lastly, 5, it's decreasing. So now try it. Write a scenario that the graph above could represent. Remember, we're talking about time and distance. So pause the video and take some participation. Okay, hopefully we got some good creative ideas. We could talk about a person walking. They leave their house and they're walking, and then all of a sudden they have to tie their shoe. So they stop for a little bit, then they continue walking, and then they stop and realize they forgot their backpack. So we're walking to school. So they have to turn around and walk home. See, this part is where they're walking, then they tie their shoe, so they're stopped. Time is passing, but their distance isn't changing. Then they continue to walk towards school. We get to a certain point and we have to stop because we realize we forgot our backpack. So we have to walk all the way back to go back home. All right, key concept. You can describe the relationship between two quantities by analyzing the behavior of the function relating the quantities in different intervals. So as time increases, the distance goes up, that's increasing. As time increases, the distance does not change, that's constant. As time increases, the distance decreases, then we stay constant and decrease again. Okay, 8th grade, let's say it. I can describe the behavior of a function and write a description to go with its graph. Have a great day.